I'm Aminu Munir. I'm the one that will take you conic section and application of calculus. So the first thing we'll start with the conic section, first before the application of calculus. So we say the first thing, what is a conic? Conic section. So we define a conic section. A conic, a conic section is a curve formed from the intersection of a plane surface and a right circular cone. That is, we form this one from a cone, just a normal cone. So, so we say this is the intersection. This is in general. So the conic section is divided into subpart, where we have the cycle is also from there, the and parabola is also from there, and ellipse is also from there. So we also have a hyperbola. So the connection of them is what is a conic section. So the fixed point is called the focus. There is a point. The fixed point on what on that point is a focus. When we come to a cycle, we'll show you a fixed point in a parabola, hyperbola, the same thing in ellipse. So therefore, a constant ratio which has denoted by small e is known as eccentricity of the conic. That is, the conic also has an eccentricity. And the fixed line is called the directrix, and we also have a directrix on that conic. So if E is equal to 1, that is the eccentricity. The eccentricity is equal to 1. The conic is called a parabola. So that when the eccentricity is 1, then the conic is a parabola. And if E is less than 1, the eccentricity is called an ellipse. That conic is called an ellipse. And if E is greater than 1, the conic is called the hyperbola. So therefore, this is just a point. So we have this axis, x axis, and we have the y axis and the x axis. So we have the distance from here to here. Any line, vertical line like this is a y axis, and any line that comes from here is from x axis. So this is a point x on the x axis, s denoted by s, and n on the y axis denoted by n. And so therefore, they meet at this point P. So therefore, the ratio we are talking about, this eccentricity is equal to 1 eccentricity less than 1 eccentricity greater than 1 is from this point. That is the ratio of what? This point and this one. So therefore, the ratio is SP, that is from here to here. When we take the ratio from this S into this P, is then we divide that this ratio divided by the ratio of Pn, that is the ratio from here to here. So it's equal to what? It's our E now. This is the definition of our E. When we take this ratio, and this ratio gives us 1, that is this ratio from here to here, then divide by from here to here and give us 1. Then we say that conic is a parabola. And if we take this ratio, this one over this one, and we have less than 1, that is the denominator is bigger than the numerator, then we say this conic is ellipse. And if we take the ratio, this SP over PM, and we get it equal to 1, that is our eccentricity greater than 1, then the conic is called the hyperbola. So therefore, we'll start, the first thing we'll just start with a cycle. Even though we've not mentioned the eccentricity of the cycle here, so we'll start with a cycle. Then, after we finish with the cycle, then we will go to a parabola. After the parabola, then an ellipse. After ellipse, then we take a hyperbola. After we finish this, then we just go to the application of calculus. So in this lecture, inshallah, we're going to just talk about a cycle. Then the next one we'll talk about the parabola. We'll be taking each lecture and taking each topic. So therefore, the first we'll just start with a cycle. Then what is a cycle? A cycle is the locus of a point which move so that it is distance from a fixed point is constant. That this is just this one, that is from here, this is just a fixed point. That is a distance from a fixed point to the end point of the cycle, this is constant. That is a distance from the center, this is the center up to what? The end point is constant, this distance. So this constant distance is called the radius. That is, whenever we're having a cycle and we're having a line, this constant, this line with a constant distance, a line from here to here is r, which is the radius. From here to here is the radius. This is what we are going to use. So we know that when we take a distance from here to here is radius, and we take from the same this point up to the end point, can have another radius from here. When we add this radius from this radius, we get a diameter. So we are not going to use diameter in this conic section. That's why we're not mentioning a diameter. So just only use radius, the distance from the center to the end point. So it's r. And while the fixed point it is center. That is, this fixed point of the cycle is what? This is the center of this cycle. So in this case, this is y-axis and this is an x-axis. And so therefore, um, this is at the origin. That is, x starting from everything here is 0. Then from here, then we just start counting the distance of x. From here, we just start counting y. So from here, this is 0. So therefore, at this point, x is 0 and y is 0. So therefore, we have this center at this kind of cycle is center of what? 0, 0. That is, at this point, normally the center of the cycle is at the point of x, y. That is the value of x, the value of y. So this cycle is at center of 0, 0. That is, from here, c is this cycle is c is to be equal to c over 0, 0. Then a cycle of center of 0, 0. So we have this. So in this case, if we have a cycle, that is, this is a cycle at the origin, and we have a shifted cycle, the one that is not at the origin. So the center of this one, like this cycle, like this. So having this one is at the origin, while this one is not at the origin, it's shifted one. And it is possible to have a cycle in the when we have a quadrant, like this 4 quadrants, it's possible to have a cycle in this quadrant, which is not in the center, and have in this quadrant, to have in the other one, and have in each quadrant. It's possible to have this. Therefore, this is the center. We have this. So then from x, we have a at this point, and from y, we have from y we have a, and from y we have b at this point. So therefore, this shifted cycle is starting from here, we just go to here, and from this point and meet at this point. So this is just the center of this cycle, the shifted one. This shifted, this is the origin of this cycle. Everything here is 0, 0. Well, at this point is a cycle of center at a, b. We don't know what is a, we don't know what is b. But when we just come to example, you can see how a and b, you can just look at it. So we have him from here, any line that will come in this direction like this is a line from the x-axis, and any line that will just go vertically like this is a line from y-axis. So therefore, we say the distance from here to this point is x, and so therefore, and the distance from here to here is a. The complete distance from 0 to this point is a, is x. So we don't know the value of this one, and from here to here is a. So therefore, this point is saying the distance from here to here means the distance from here to here then minus the distance from here to here. That is x minus a. So the complete distance is x. So therefore, from here to here is a. So then the distance between here to here is this x. The whole x remove a. When we remove a, we just remove this part. Then we have to remove this point. And having the distance from here to here is y. And this is why we just locate this arrow. From here to here is y. And from here, the distance from this point to this point is b. So therefore, to calculate this point from here to here, this means the whole this one minus from here to here. That is, from the whole the whole distance is y, and from here to here is b. So therefore, to define the distance from here to this point, so we say this is y minus b. That is the complete y. Then we just remove it from here. So in general, this is just a what? The radius of the cycle. This is r, and this is just another radius r at the center of a, b. So here we have this is the center of x, y. The same thing at the center of a, b. We have it from here. Then the equation of this cycle, that is the equation of a cycle. The equation of this cycle at the origin of a cycle at the origin. The equation of this cycle at the origin is defined to be x minus 0, that is x is 0, that is x minus is the value of x at this point, 0. then all x square plus y minus the value of y at this point, that is 0 at the origin, is equal to r square, where we define our r square to be the radius, just r to be a radius, and the equation is given to be on this form. That is, from here, this is implying we are having x squared, this is x squared plus y squared is equal to r squared. That is x minus 0 is x, then squared, we are having x squared, then plus y minus 0 is y, then we are having y squared, which is equal to the radius r squared. This is the equation of the cycle at the origin. So we have x squared plus y squared is equal to r squared. Then the equation of the cycle, not at the origin, that is the shifted cycle, the equation of the cycle at the center a comma b, where a and b can be anything. So therefore, this is something as x minus the value of a, that is x minus the value of x, that is a. Then we say all squared plus y minus the value of y at this point. Then y will be, then all square is equal to r squared. This is just the equation of the cycle, not at the origin. That is the equation of the cycle at a comma b, where a and b is the center of the cycle. So we have this. So let's look at example. Example. Let's look at example. This example is saying find the equation of the cycle. That is, find the equation of the cycle whose radius radius is 3. Radius is 3, and whose center is at 1 minus 1 over 2. So we have this one. So we find the equation of the cycle whose radius is 3 and whose center is minus 1 over 2. So now when we say solution, the radius is our r. Comparing with this one, we're having this is center at a comma b. So therefore we're having x minus a whole square plus y minus b whole square is equal to r square. So when we compare with this one, then our a is minus 1 and our b is 2. Then our r is 3. Then we say the required equation is so having x minus a, where our a is minus 1. So therefore having minus into minus 1, then all a squared. Then plus y minus b, that is 2. So we're having y minus 2 all squared is equal to r squared. And r squared is the radius, so the radius is 3, so it's equal to, this is 3 squared. Therefore, we're having x, the minus is plus, so we're having x plus 1, then all squared, then plus y minus 2 all squared is equal to 3 squared, which is 9. 3 by 3 is 9. So yes, we can expand this one. Expansion of this one, this square means x plus 1 into x plus 1. Then plus, from here we're having y minus 2 into y minus 2, which is equal to 9. This by law of industry, we can split this bracket into 2, and we can also split this one into 2. Now we can just expand the bracket. So we're having x times x, so we're having x squared x times 1, we're having plus x. Then 1 times x, we're having plus x. 1 times 1, we're having plus 1. Then plus this side, y times y, so we're having y squared. Y times minus 2, so we have minus 2y. Then 2 times y, we get minus 2y. Then 2 times minus 2, so minus minus is plus. So having 2 times 2, so 4 is equal to 9. And so therefore, we can add this together. So we have x squared plus x plus a, so we have 2x, then plus 1, then we have plus y squared, then minus 2y is minus 4y, then plus 4 is equal to 9. So we can take this one 9 to this side. So that now this term is squared, then we just add them in one side. Then term without squared, we just add them in one side. Then the constant in here. So therefore, this x squared, I can take this y squared to this side and can pick this 2x and merge it with this y. Then I can take this 9 to the other side. So therefore, doing that, we have x squared plus y squared plus 2x, then minus 4y. Then this 1 plus 4 is 5, then plus 5. Then I can take this 9 to this side. I can have minus 9 is equal to 0 from here. Then we have 5 minus 9, we have x squared plus y squared plus 2x minus 4y. Then 5 minus 9 is minus 4 is equal to 0. So this is the required equation of the cycle. This is the required equation of the cycle we are asked to find. This is the equation. So from here, we can also be given this equation to find the center of this cycle and radius. So this will be given to find the center and radius. So I can also take this question to go back to there. So suppose this question is given. Find the center of this cycle and the radius. Find the center and the radius of this cycle. So I can write it as another example 2. Example 2. Find the center and radius. Find the center and radius of the cycle, of the equation of this cycle. Yes, of the cycle. From the equation. From this equation, so we have x squared plus y squared plus 2x minus 4y minus 4 is equal to 0. Then we say solution. So find the center and the radius of the cycle from the equation. This x squared plus y squared plus 2x minus 4 minus 4y minus 4 is equal to 0. That is, from here we will be given the center and the radius to get the equation of the cycle. So we can also be given the equation of the cycle to find the center and the radius of the cycle. So let's see. The solution will have been x squared plus y squared plus 2x minus 4y minus 4 is equal to 0. So in here we are going to use the completing the square method. So we take this 4 to that side. So therefore, in plan we're having x squared plus y squared plus 2x minus 4y is equal to 4 when it's turned to that side. And so therefore, by using completing the square method, we say take the coefficient, take the half of the coefficient of x and y, square it and add it to both sides. Like this, take the coefficient, take the coefficient of x and y, square it, and add it to both sides. That is, we just take the half of the coefficient of x and y. Each, we just have take the half of the coefficient of this, square it, take the half of the coefficient of this, square it, and just add it to both sides. So the half of the coefficient of x is 2. So then half of it means we just divide this 1 by 2 and we can get 1. Then square it is implying we get 1 squared. So half of the coefficient of y is minus 4. Half of it, we just divide it by 2, which is equal to, we can get minus 2. Square it is implying we are just taking the square of minus 2 squared. And we just add them to both sides. So we have x squared plus y squared plus 2x minus 4y, then plus the coefficient of x that we already square it, then plus 1 squared, then plus the coefficient of y, the half that we already square it, then plus minus 2 all squared is equal to 4. Then we say we just add it to both sides. We add this one in this side, we have to just also justify it. We just add it to this side also. Then plus half of the coefficient of x that we already square it, then plus the half of the coefficient of y that we just square it. We just add them to both sides. So from here, simplifying this, so by using completing the square method, while we just have the take half of the coefficient, we mean this coefficient half, we just take it and add it to this x, and y, we just take the coefficient and just take them on one side. So therefore, from here is implying we get x plus this coefficient, that is plus 1 all squared, then plus y, then plus this coefficient minus 2 all squared is equal to, so we have 4 plus 1, which is 5, plus 4. So we have 9. So therefore we have 9. So this implies comparing this one. So we comparing this with x minus a all squared plus y minus b all squared is equal to r squared. Then from here, this is the equation of the circle as center of a comma b. So therefore, we are having x minus a whole square plus y minus b whole square is equal to r square, where r is the radius. So comparing this one with this one is implying our x is equal to minus 1. From here, we can say x plus 1 will just equate it to 0. So therefore, let me do this step. X plus 1 is equal to 0. So implying x is equal to minus 1. And from here we get y minus 2 is equal to 0. So implying y is equal to 2. So therefore, the center of this cycle, at the center is at x comma y, which is something as x is minus 1 then comma 2, which is the same thing as the center of the cycle given to us. So that in this cycle we can take it back to the center and the radius. And so therefore from here, our r squared, so we are comparing this with this, so here is 9 and here is r squared. Imply r squared is equal to 9. R squared from here, we just imply r squared is equal to 9. So taking the square root of both sides is implying r is equal to 3. That is the radius, we already get back our radius, which is 3. So therefore we say the center, since the question is find the center and the radius of the cycle from the equation given. This is the equation, so we need to find the center and the radius. So the center is at -1, 2, and the radius is equal to 3. So we can now say the center is at -1, 2, and the radius is 3. So this is all about this one. Then therefore, let's look at another question. So the next example 3. So this example 2 is also saying find the equation of the cycle. Find the equation of the cycle with center. So with center 3, -2, which passes through the point -1, -3. So therefore, find the equation of the cycle with center and base, which passes through the point -1, 2. So this is the center of the cycle. So we need to get the equation. So the radius now is the radius of this cycle is the gradient from the point, this point what to this point. So now we can now say solution. So we have the center. So I mean the equation of the cycle at a comma b is given as x minus a plus y minus b all square is equal to r square. This is the general equation at a comma b. So having x minus a all square plus y minus b all square is equal to r square. So therefore we say find the equation of the cycle with center at 3, -2. So this is the center. So comparing with this one, we have our a is 3 and our b is -2. So therefore we have x minus 3 all squared plus y minus, then we're having 2 here, -2. So here minus into -2, then all squared is equal to r squared. And so therefore we're having x minus 3 all squared plus y, here we get plus 2 all squared is equal to r squared. And so therefore, then you have to get the radius. R is the gradient now. Our radius now, R is the gradient. Okay. Find the equation of the circle with center at 3, -2, which passes through the point. This one and this. So it passes through a point. The center is here and passes, that is, to sketch this one, we're having a cycle like this. We're having a graph of the function. So x is 3, so having x is 3 in here. And y is -2. So therefore y -2 is from this side. So therefore we can locate this one and locate this one. And this is a point of 3, -2. So this is the center of this cycle now, which passes through the point, this one. And this is passes through the point -1 or -2. So that is x is -1 and y is -3. So we can sketch this one as x is -1, so we are having x -1. That is from here to here is positive x and here is positive y. Then anything from here downward is negative of y axis, and from here to here is negative of x axis. So therefore x is -1 and y is -3. So therefore -3 is around this point. So around this point, so we have this point, this then will get this is the point of -1, -3. So we find the equation of the cycle that passes through here. And it is passing through this point. The equation of this cycle is passing through this point. It just passes like this and go. And so therefore we have the distance, it just passes through this point and have it like this. So that this from here to here is the radius of this cycle we are going to find. Is the radius of this cycle. So therefore from here to here is r. Now r is the distance between this point to this point. So now we just define a distance. And recall that the distance between two points, that is giving a point this one and this point. So to get the distance between this point and this one, so this implies the distance between 2 points d is given to square root of x2 minus x1 all squared, then plus y2 minus y1 all squared. This is the distance between 2 points. The distance between here to here is defined to be this. So now, as our r, this point is our x1, this one is our x2, this one is our y1, this one is our y2. So therefore, the distance between 2 points is defined to be this. So now, the radius, we need to get the radius. The radius is the distance between this point to this point. So now we define our r, which is the radius, is to be defined to be the distance between, from here it passes through this one. This one our x1, y1, here is our x2, y2. So therefore, from here we're having r defined to be x2 minus x1 all squared, and this one then we're having y2 minus y1 all squared. So this is equal to square root of our x2, which is this one, minus 1, then minus x1. x1 is 3, so we have minus 3, then all squared. Then plus y2. Our y2 is minus 3, so we have minus 3, then minus y1. Our y1 is minus 2. So therefore, this is minus into minus 2, all squared. This is equal to, so we have this square root of this minus 4. So we have minus 4 all squared, then plus minus 3. This we have minus 3 into this one is plus 2 all squared. And so therefore we can have this one to be r is equal to square root of, this is minus 4 squared, this is 16 plus, this is minus 3 plus 1, which is minus 1 all squared. And this is defined to be, this is 16 plus 1. We have the 16 plus 1. And therefore our r is equal to square root of 16 plus 1 is 17. Our radius is square root of 17. So therefore r squared here is implying our r squared is equal to square of both sides. So we are having 17. Our r squared is 17. So substituting this one into this is implying, so from here is implying x minus 3 all squared plus y plus 2 all squared is equal to r squared, and our r squared is 17. So we have 17. So we get this. So the question is saying find the equation of the circle which center is which passes through the point, this one. So this is just the equation. So just expand this one. We get the equation of the circle. So here we're having expanding this one, we're having x minus 3 into x minus 3. So because of this 12, I don't know this, we can split this one into 2 like this. Then plus, from here we have y plus 2, y plus 2, then into y plus 2 is equal to 17. So therefore from here we just expand the bracket. So x times x will have been x squared, x times minus 3 will be minus 3x, minus 3 times x we have minus 3x, minus 3 times minus 3, so minus is plus, then we have 9. Then plus expansion of this side we have y times y, we get y squared, then plus y times 2 we have 2y, plus here we have 2y, then 2 times 2 we have plus 4 is equal to 17. So therefore we have, so we can just, the term is squared, we just add them on one side, and term without square just on one side. So we can take this 17 to come inside. So here we have x squared minus 3x minus 3, we get minus 6x plus, plus 9. So therefore we have plus y squared plus 2y plus 2y, we have plus 4y, then plus 4. Plus 4, then we can take this 17 inside, so minus 17 is equal to 0. So therefore, term is squared, we just bring them on one side and the other hand we just bring them on one side. And so therefore, we have x squared, then plus y squared, then plus y squared, then minus 6x, then plus 4y. So we have this, then 9 plus 4, which we have 13. 9 plus 4 is 13, and 13 minus 17. So therefore we have minus 4. So therefore this minus 4 is equal to 0. So this is the equation of the cycle. So from our question is saying find the equation. This is the equation of the cycle. So we have this. So in general, the general equation of the cycle can be derived as just the general equation of the cycle. Right? So the general equation of the cycle is given by having x minus a all squared plus y minus b all squared is equal to r squared. Now, so from here we can just expand it like a normal expansion we normally used to do. And then we have x minus a into x minus a, then plus y minus b into y minus b is equal to r squared. And so therefore from here we just expand. X times x, so having x squared, y, x times minus a, having minus ax minus ax, then minus a times a, we get minus ax, then plus y times y, we having y squared, then y times minus b, we get minus by, then y minus b times 4, we get minus by, minus b times minus, so minus minus is plus. Then we have b times b, which is b squared is equal to r squared. So then from here, we can say this is x squared, this is minus ax, so we have minus 2ax plus y squared. So we mix something somewhere. Minus a times minus a, so we mix it from here. So we mix something in this expansion. So I mean from here to here there is some mixing. Next time we say we get x squared. Then x times minus a, so we have minus ax minus a times b, we have minus ax. Then minus minus is plus, say we having a times a, we having x squared. This is what the correct expansion. Then from here we get x squared minus ax minus ax, so we having minus 2ax, then plus a squared plus y squared, then minus by we have minus 2by, then plus b squared is equal to r squared. So when we just expand like this, then we can have this. So therefore, we can take this r to this side. We can take this r to this side. So we're having x squared. So the term with square, we just add them in one side. Plus y squared, then minus 2ax minus 2by. Then this one and this one, so we're having plus um, a squared plus b squared plus minus r squared. When we take this one to this side, we get minus r squared is equal to 0 from here. And so therefore, so this we can say this implying we get x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So this is general expression of cycle. Where what is this g and what is this f coming from and what is this c? So we define where this minus 2a is equal to g. That is, we let minus 2a to be equal to g. So therefore, this is where we have this one. Minus 2a to be equal to 2g. Minus 2a to be equal to 2g. So therefore, we have this minus 2a to be 2g. So we can have this one. And we have the minus 2d to be equal to 2f. So this is where they are coming. So just let this one 2f to be minus 2b. So minus 2b is equal to 2f. Then where c is this one. So where c is equal to a square plus b square minus r square, which is a constant. So this is the general equation of the cycle we are having. So therefore we note. So in here we have the highest power, the equation of the cycle. What will look if we just look at the equation to know, is this equation of the cycle or not? So how can we understand this equation is an equation of the cycle? So by looking at the equation, we say the highest power is 2. The highest power of x and y is 2. This is the first thing we are going to look at. Then the next thing we are going to look at, there is no term of, and the coefficient of x and y must be equal. Coefficient of x squared and y squared must be equal. That is, the highest power of x is 2 and the highest power of y is 2. This is the first value we are going to look. Then the next thing, the coefficient of x squared is this, must be the same thing as the coefficient of y squared. As this one, the coefficient is 1 and the coefficient is 1. And if you have get 2 and here, this must also be getting what? 2. That is, the coefficient must be the same thing, x squared and y squared. Then the next thing, there is no term of xy. The term will be product of x and y at the same time. So therefore, these are the three things you are going to look, and you know that yes, this is the equation of the cycle. You know that the squared, the highest power is 2, power of x and y is 2. and the coefficient of x square and y square must be the same thing, and the term with, we don't have any term with the xy, so you can just only have only 2g. This 2g is constant, then we're having y. We don't have two. Once you see 2g xy, then this one is not the equation of the circle completely. This is not the equation of the circle. Or you see y something, so we don't have any product of two variable to be the equation of the circle. Okay, the next thing is to find the coordinate of the circle, which we has already done. Then the tangent of to a cycle. So the tangent to a cycle. Tangent to a cycle. So what is a tangent? A tangent is a line, a tangent to a curve is a line that touches the curve at a point. Just a line that does touch a curve at the single point. If we're having a curve, so the tangent to the curve is the line that just touches the curve at only one point. So here we're talking of a circle, not in general curve here. So we just draw our cycle. So we're having a cycle at the center, at any center, either 0, 0, or 0. So we know that this one is a cycle, and this is the center of the cycle. And so therefore we have been our radius r. So from here to here is our radius r. So from here, a tangent is a line that touches a curve. A tangent to the curve. Now we are talking about the cycle now. A tangent to a cycle is a line that touches a cycle at only one point. That is a tangent. A tangent is this line that just touches the cycle and just go. So this line is a tangent line. This is a tangent line, but this is the radius. So we find this to be, this is the radius. And we say always, the tangent line is always perpendicular to the radius of the cycle. The tangent to a cycle is always perpendicular to the radius. Perpendicular means this one is in here vertical, this one will just come to this one like this. So have this line is straightforward from here, and you have the radius from here. So this tangent is always perpendicular to this. Like if you are having this line, this is not a tangent line, because it's touched this cycle at this point as it touches again at this point. So therefore this is not a tangent. This line is not a tangent. But this one is a tangent, the one that will just touch it at only one point and just pass. So that is the tangent of the cycle. So let's find the equation, example on the tangent of the cycle. Let us look one example on this one. So the question is saying example I think number 4. We say find the equation of the tangent. Find the equation of the tangent to the cycle x squared plus y squared plus 4x minus 10y minus black is equal to 0 at the point at point at the point 3, 1. we find the equation of the tangent and this. So we say solution. So given a cycle, the first thing we are going to do here is we are going to find the center of this cycle. Then we use the center of the cycle to find the equation of the tangent. And every equation has a slope. So therefore, the slope we are going to find here, after we just find the center of this cycle, then we use the center at a comma b, any value we have, then with this one to get the slope. Then the slope we are going to get first is the slope of the cycle. And then therefore we take the tangent, the inverse. Okay, when we just come to there, we see. Therefore, we have been x squared. The first thing we are going to just find the center of this cycle and the radius. These are the first thing we are going to do. So I have x squared plus y squared plus 4x minus 10y minus 12 is equal to 0. So here we use, by completing the square method, that is we take this 12 to the other side. So we get x squared plus y squared plus 4x minus 10y is equal to 12. So we have this. So therefore we say take half of the coefficient of x and y, square it and add it to both sides. That is, we have x squared plus y squared plus 4x minus 10y, then plus the coefficient of x is 4, half of it is 2, then square it, so we have 2 squared, then plus the coefficient of y is minus 5, so half of this one is minus 5, so then square, so we have minus 5 squares as we did in the last example, which is equal to 12, then plus what we add from here, we just go and justify and add it in this side. So therefore, we're having plus 2 then square plus minus 5 all square. So therefore, from here we have x plus 2 all square plus y minus 5 all square. That is, we just add the half of the coefficient of this one after we just square it. So we mean x plus 2. When you expand the bracket, this x plus 2 will give you x squared plus 4x plus this 2 square, which is 4. And when you expand this one, we can have y squared minus 10y plus minus 5 squared, which is 25. So when you just expand this one, you can get back to there. So this is equal to, from here, we're having 12 plus 4, then here plus 25. So have it. So therefore here we have x plus 2 all square plus y minus 5 all square is equal to, so here we are having 12 plus 4, so we get 16. 16 plus 25. So you see 10 here, we have 12 plus 4 is 16, and 16 plus 25, so therefore we can get 31. So therefore we can have 31. 10, 10, 30, 6 plus 41, sorry, is 41. So we can have 41. One will just add this together. So therefore it's implying the center of this cycle, the center is at minus 2, 5, and the radius r is equal to square root of 41. Now this comparing with all what we have done, this will have been r squared is equal to r squared, implying from here r squared is equal to 41. And we just need r is equal to root of 41. So have it. So the center is at minus 2, 2. So therefore now, so we say find the equation of the tangent to the cycle, this one. and the point is that this tangent is also has its equation. That is, this circle has its equation, and the tangent also have its equation. So that we are going to get the equation of the tangent now. And the equation of the cycle in general is we have to find the equation of a cycle. We need a gradient. That is, so here this is what we have done. What we have, so this is our, then the gradient, that is the slope. Let's get the slope. The slope is m, which is equal to y2 minus y1 all over x2 minus x1. This is how to get the slope of the equation of the tangent. So this is the slope. And here we have this one is our, the point given is x1 and y1, and what we got now is our x2 and y2. Okay, so therefore we have been x1 y1 to be equal to, no, the one we have got is our x1 and y1 is the one we have got now, and the one given, so we can find x1 and y1 from here, and the x2 and y2 is already given. So therefore x1 and y1 is the one we can have minus 2 comma 5, and our x2 y2 is equal to the one given, the point given already. So we have 3 comma 1. So therefore the slope m is equal to y2 minus y1. So our y2, which is 1, so having 1 minus y1, which is 5, then all over x2, our x2 is 3, so having 3 then minus x1, which is minus 2, and this is equal to 1 minus 5, 1 minus 5 all over 3 plus 2, and this is equal to minus 4 over 5. So this is the slope, and this slope we have got is the slope of the cycle. This is to get the slope of the tangent. So this slope is the slope of the line that is perpendicular to the tangent. So therefore, in this case, we say always the radius is perpendicular to the tangent. Whenever we mention a tangent line, then there is a normal line. So the slope we got first is the slope of the normal. Even though we are not talking about the normal, but we have to take this one back into the slope of the tangent. So the slope is given saying the slope of the tangent multiplied by the slope of the normal is equal to minus 1. And so therefore, if we need the slope of the tangent mt is equal to minus 1 over the slope of the normal, that is m. And in this case, we are having minus 1 over, the first one we get is our m, which is the slope of the normal, the first one. So we get minus 4 over 5, which is equal to this minus cancel minus, and the 5 will go. So we have 5 over 4. So now this is the slope we are going to use to get the equation of the cycle, and the equation of the tangent. So this is the slope we are going to use. So therefore, the equation of the tangent is given by y minus y1 is equal to mt, that is, so I can write the equation of the tangent is given by y minus y1 equal to mt, that is the slope of tangent into x minus x1. So therefore, we have substituting y minus y1. So our y1 here is minus 2. This x1, y1. So therefore, x1 is minus 2 and y1 is 5. So our y1 is 5. So therefore, we get minus 5 is equal to our empty now. The equation of the slope f is equal to 5 over 4. So we get 5 over 4 into x, then minus x1. Our x1 is 2 and y1 is 5. So our x1 is minus 2. So we get minus 2. So here we get y minus 5 is equal to 5 over 4 into x. This is then we have plus 2. Minus minus is plus, so we have plus 2. So close this one to that side is implying 4 into y minus 5 is equal to 5 into x plus 2. So I have this one. So we just expanding the bracket, we get 4y minus 4 times that we have 20 is equal to this by that we have 5x, this that will be plus 10. So we can take them to this side. So we have 4y minus 20, 4y minus 20 minus 5x minus 10 is equal to 0. So this is implying 4y minus 5x minus 10 minus this is minus 30 is equal to 0. So from here, this is just the equation of the tangent. So inshallah, if you enjoy this video, you can subscribe so that we can continue next week by parabola. So now we'll just start with the circle. Then remain, we'll just remain parabola, hyperbola, and ellipse. Then before we enter into the conic section. And if you like this video, you can just subscribe. Inshallah, we'll meet next week.